Hello guys, my name is Gaurav Yadav. Welcome to Ask IITians. Right? I hope you all are doing well. Today we'll discuss about surface area and volume. We'll do a session surface area and volume of the 10th standard. This is quite very much important for your board exam and also for not only your board exam for your Olympiad, Housman and TSE, right? For various exams also. Just wait a while, I will share my screen. Yeah, perfect. Right. Yeah. So we'll discuss surface area and volume. Let me tell you that this board weightage is 7 marks, right? We'll start from the very basic and we'll cover some topics like uh, volume of combination of solid, volume of combination of solids, conversion of one solid into another by melting. By melting, you can convert. Let me tell you here only that if you convert one solid into another, if you convert one solid into another, then guys its volume remains the same. Its volume remains the same, right? Its volume remains same. Okay. Then we'll discuss about custom of a coin. Custom of a coin. Okay. Okay. For today, like in 2021, your custom of a coin is excluded from your board's perspective, right? In your board's custom of phone is excluded, but if you go for your completion and also for your Olympiad one, custom of phone is quite much important. Okay, so there are some solids like your bucket. Bucket is basically your custom, custom of your coin. A street cone, whenever you see, it is just basically like the VLC player in our lucky, right? It just shaped like a VLC player, right? So the street cone that is used for your barrier on your roads, right? It is basically a cone. Okay. Your glass, your glass is a we can treat a glass as a hollow frustum, hollow frustum, or also like yeah, this glass is a hollow frustum. Otherwise, it is a right circular cylinder, and hollow one, then it is a hollow cylinder, hollow cylinder. Okay. So these are the basic topics we are going to discuss for today only, right? Volume of combination of solid, conversion of one solid to another, and your custom of component. We'll move further. The first point is volume of combination of solid. Like how will you calculate your volume? How will you calculate your volume of combination solid? If we see in a real life example, there are many shapes which are formed by combining different shapes. For example, a tent is formed by combination of a solid of cone and cylinder shape. Very good. Like yeah, if whenever we see a tent is like a cylinder is there, a cylinder is there basically, and a cone is there above it. It is a tent is there. So a tent is basically a combination of both cone and your cylinder. If you need to find out the total volume of this object of this tank, then you have to add both the volume of cone and both the volume of cylinder, right? Okay. Similarly, ice cream cone is a combination of a cone and a hemisphere. Very good, right? Whenever you eat ice cream, you get like example is given. Whenever you eat a cone ice cream, a cone is there and also a hemispherical. The top cream is also there, right? So it is basically a combination of your hemisphere and your cone. Okay. If you need to find out the total volume of your ice cream cone, then you have to add both the volumes. Okay, right? Yeah. Then hence the volume of this combination of solid will be equal to the sum of the volume of individual solid. It is quite clear by your observation. Like if a combination of solid is given, then if you need to find out the total volume, then you have to add individual solids. For example, a capsule is also given. How capsule is made? Just take a right, just take a right circular cylinder and two hemispherical ends. Two hemispherical ends. Okay. Yeah. So basically, volume of combination of solid is just add the individual volume. You will get the volume of entire solid or entire item, right? Okay. For a cuboid, you know the basic formula. For example, your cuboid is basically a rectangle and a 3D figure of it, and a 3D figure of it, a rectangle and a 3D figure of it. So in rectangle, there are only two dimensions are there and B, and if you add your H also, then it becomes a cuboid. You know the TSA of cuboid two times uh, two times of LB plus BH plus HN, right? If you subtract the top and bottom base area, you will get the volume or your CSA, or can say the area of four walls, that is 2H multiplied by L plus B, right? You need to find out the volume. The volume is LBH, total summation is also given there. And yeah, right, the length of diagonal of cuboid. The length of diagonal of cuboid is under root of L square plus B square plus H square, right? So, for cube having AX length of X, you know, cube is a 3D figure of your square one. Okay. And if a cube is your a length of X, then total surface area will be equal to 06A square, your CSA. Let me write here CSA. CSA of cube is your, just subtract the bottom area and top area, you will get the 4x square, right? If 6x square minus 2x square will be equal to 4x square. Length of the diagonal is x root 3 or your root 3x, right? If your length of the diagonal. Similarly, yeah, right. Similarly, your volume of sphere is 4.3 pi r cube. Your volume of cone is 1.3 pi r square h, and your volume of cylinder is pi r square h, and your volume of hemisphere is 2.3 pi r cube. I think yeah, you all know the basic formulas and basic volume formula, total surface area formula, and curve surface area formulas of different solids, right? We'll now do a good question, a very good question based on combination of solids, right? So question is a cylinder of volume 150 cubic centimeter. Cubic centimeter is centimeter cube basically, right? So you know the volume of cylinder is given, that is 150 centimeter cube. Is placed with a cone whose height is 4 centimeter. A cone is given whose height is 4 centimeter. Just look at the diagram. If the height of the cone and cylinder is equal, it means the cylinder height is also 4, right? Both heights are same, equal to 4. Find the total volume of the shape formed by combination of cylinder and cone. Okay. You need to find out the total volume of combination of solid. 150 centimeter cube is your volume of cylinder. Volume of cylinder. Okay. So guys, what is the formula of volume of cylinder? You all know pi of r square h. Clear? If you take r, both r's are same in case of cylinder and in case of cone. 150 is going 150 is your basically your volume of cylinder, that is equal to pi r square h. You know the value of pi. You know the value of h. You will get the value of r. Okay. You will get the value of r. Just you need to find out the volume of combination of solids. So volume of whole solid, volume of whole solid will be equal to your volume cylinder plus volume of your cone, right? Volume of cylinder plus volume of the cone. What is the volume of cylinder, guys? You know the volume of cylinder is 150 given. So you don't need to write the whole formula, right? What is volume of cone? Volume of cone is 1 upon 3 pi r square. Let me tell you here r and h both are same. So you can also write pi r square is equal to 150. Also, yeah, you do not need to find out the value of r. Just put the value of 150 here in pi r square. So 150 over 3 will be your 150 over 3. 50 plus 150 will be 200 centimeter cube. Like it. So whole combination of solid, like without I haven't, if I have I do not want to calculate the value of r, right? Because here O whole h and r are both same. H and your r are both same. So you can just add, like volume cylinder is pi r square and your volume of cone is 1 upon 3 pi r square. Take out the comma pi r square. 1 plus 1 by 3 will be your 4 by 3. Just 4 by 3 of pi r square. Also you know the volume of like the value of pi r square is 150. Then 150 upon 3 will 50. And 50 into 4 will be your 200 centimeter cube. Okay. So you do not need to find the value of r. If question asks that find the value of r, then make the formula 150 centimeter cube equal to pi r square. You know the value of h. Just find out the value of r. Right, guys? So this is the basic solution. Just go through it. The same thing we are doing. Okay. Okay. So the topic is conversion of one solid to another. When you convert one solid shape to another, its volume remains the same, right? No matter how different the new shape is. Very good, right? You know the mass can never be created, nor be destroyed. You can't create a mass. You can't destroy the mass. Only your shape can change. Okay, and while shaping changes, only your volume remains the same. A good example is given right there. A good example, a bar is given, bar, or you can say a brick of steel, right? So if you convert a brick of steel or a bar into your spherical balls, small spherical balls, okay, what will be there? Like if suppose that if a bar is there, a bar is basically a brick. If we need to convert this into spherical ball, several spherical balls. If I gave a question that a bar, like this volume, if you need to convert these into spherical balls, then volume of your brick will be equal to, suppose that each spherical balls have same radius. Then suppose that seven spherical balls you can make from a brick, right? So volume of brick will be equal to 7 times the volume of your ball, spherical ball. I think it is clear that if you need to convert one solid into another, just equate the volume of one solid to another, right? In fact, if you melt one big cylinder, like example is given, if you melt one big cylinder candle to five small cylindrical candles, the sum of all the five small cylindrical candle will be equal to the bigger one, right? Suppose if a candle is there, right? If a candle is there, you need to convert these candle, or you have melted these candle, or reshape these candle, a big candle, into small candles, right? Into small candles. What you need to do, and you are given that it is only five candles are made from these. Only five candles are made from these. So what you have to done is your that volume of your bigger candle. I will write B. Volume of your bigger candle will be equal to 5 times the volume of your small candle, right? So basically, our formula is just convert one solid into another. Then keep in mind that while converting one solid into another, the volume of one solid is equal to the volume of another solid, right? Okay. We'll do a question based on conversion of one solid into another. Okay. So a copper rod with diameter 1 centimeter. Note it down. A copper rod with diameter 1 centimeter and length 8 centimeter is drawn into a wire. Question is that a copper rod was there of diameter 1 centimeter. Guys, if diameter is 1/7, it means its R will be equal to 0.5 centimeter, right or not? Obviously, a copper rod is there with diameter 1 centimeter. It means its radius is 0.5 centimeter and length is also given. Length is given 8 centimeter. So you know value of R and value of L. L is basically your edge. Why? So a copper rod is basically a cylindrical form, right? So you know the value of R, you know the value of L. So it means you know the value of pi r square. And what is pi r square? Pi r square is basically your volume of your copper rod. Okay. Uh, then it is converted, right? It is drawn into wire of length 80 meter of uniform thickness. Just determine the thickness of the wire. So you are given that a copper rod of diameter 1 centimeter and length 8 centimeter is drawn into a wire of length 80 centimeter. It is so beaten up, like its length has increased to 18 meter of uniform thickness. Suppose the thickness is T. Suppose the thickness is T. Then what you need to do, just equate the volume of your copper rod to your volume of your volume of your wire. Okay, you will get the value of thickness. Why? Because H is given, R is also given in form of T. Okay. The main point is to just look at your units. Equate the unit also, like centimeters given and 18 meters. So just convert first 18 meter into 18 into 100, like 1800 centimeter. Okay, so first we'll calculate the volume of rod. Volume of rod will be a pi of r square. What is r? 0.5. Or then we also do by 1/2. Okay, so 1/2 whole square into your length. What is length? Your 8. So it is basically your 2 pi. You know the volume of copper rod is 2 pi cubic centimeter. Okay, and suppose that wire we have drawn into, suppose this thickness is T, or here in your solution this thickness is your R. Okay, we have calculated R. Okay, so your 2 pi will be equal to your pi R square. R is your basically your thickness of that whole wire, R square into H. What is H? H was given. H was given 18 meter. 18 meter is just basically 1800 centimeter. Guys, be very careful for regarding units, right? Because here it was centimeter cube, and you also need to convert 18 meter into centimeter to, and we are also taking your thickness R in centimeter. We are supposing that your R is in centimeter, right? So just equate it and get the value of R. R is basically your 1/30. So 1/30 centimeter. Okay. So R is basically the drawn wire. You are taking this R. This R. But the question asks what will be your its thickness. Thickness is basically your diameter. So diameter is equal to T. Your thickness is equal to 2 times of R. If your R is 130, then T will be your 2 into 1/30, that is 1/15 centimeter. 1/15 centimeter. I hope guys this is clear. Okay. Just convert one volume into another. If it is converting one volume into another, just equate the both volume and get the value, right? Okay. So 1/15 of centimeter will be your thickness. Okay. The very be careful regarding your units. If it is centimeter, just convert the meter to centimeter, right? Okay, so the important point is your first term. Oh, just look at the diagram. You will understand what first term is. Just look at the diagram. So basically, a cone was there. A cone was there. You have just cutted the upper cone by a plane parallel to its base. A cone. Let me draw. A cone was there. A cone was there. I have cutted the upper cone by a parallel to its base. Then this diagram will be formed. It is just like a bucket. This is just like a bucket we use in our home, right? So first term, so a cone was there. That cone was having only one radius. Now, if like you have removed the upper cone, the smaller cone, so two radius will be there. A smaller radius and your bigger radius. The height of the first term and your L is your slant height. So we'll go definition. A first term, a cone is cut by a plane parallel to the base of a cone. Then the portion between the plane and the base is called first term of cone. Right? Let me tell you that first term of a cone is excluded from your 10th board. It will not come according to your CBSE rule. Okay, it is excluded. Okay, but you should know, you should study, right? It will come your Olympiads or your further studies also, na? So, volume of first term of cone is, let me write. Yeah. So basically, volume of first term of a cone is one upon, you know the volume of cone, 1 upon 3 pi r square. This side 1 upon 3 pi h, and in case of r, this side r square plus small r square, because two r are there, plus r into r. Correct? It is a volume of frustum. Okay. LSA or CSA, right? You know the CSA of cone pi RL, but here now L are two, capital R and small r. Just write capital R and small r into pi L. So total surface area, total surface area. In case of total surface area, just add upper top and bottom area. Okay. In case of whole cone, we just write pi RL plus pi R square. But here two bases are there, top one and base one. We have to add individual. So pi of small r square plus pi of capital R square. Just take pi common, r square plus r square, right? Just add between them, you will get the value of PSA. PSA is pi of r square plus r square, pi of L r plus r, right? Area of base, area of top is plus area of lateral. Okay, your lateral is your top surface area. Okay, the important point is your L. In case of cone, L square is equal to x square plus r square. But in case of first of a cone, L square is equal to r square minus r square. I will tell you why. Yeah. If this is L, right? If you draw a perpendicular to this, it is perpendicular. You know this is also X, but what will be this distance? This distance is basically your R minus R, right? If I talk about triangle A, triangle B, and triangle C, your AC length is your hypotenuse, right, which is L. So L square will be your X square plus R minus R ka whole square, right? Okay. Okay, so we'll do a question based on custom. A cone is cut by a plane horizontally. A cone was there. That is draw diagram. A cone is cut by a plane horizontally. A plane horizontally, and you have cut a cone. The radius of the circular top and base of a frustum are 10 meter and 3 meter. The radius of circular top and base of frustum are 10 meter. I think it is written. It is written reverse. Obviously, the base one will have big radius, so 10 meter and your 3 meter. Let me draw first one, right? So this is basically your first one. So upper radius is your 3 meter and your base one is your obviously bigger, so 10 meter. Also height is given. What is height here? 24 meter. 24 meter. Okay, if the height of the cone is 28 meter. Okay, so height was given, total height of the cone was 28 meter. Find the literal surface area of first term. For literal surface area, just calculate the value of L, then pi of L, R plus R into all. Just calculate the value of L. You will get the literal surface area of first term, right? Just calculate the value of L and also L square. L square is equal to your x square plus r minus r the whole square. You know the value of x. X is your 24, r is your 10, and small r is your 3. So we have calculated value of L. L comes out to be your 25 meter, right? What is LSA or lateral surface area? Lateral surface area is pi L, capital R plus small r. You know the value of L, we have calculated. Capital R is also known 10, then small r is 3. 10 plus 3 is 13, 13 into 25 is 325, 325 5 meter square. So we have calculated your CSA. CSA is basically your 325 meters. I think guys, this question is very much clear for Frustum of our phone. Now we'll move forward. These are basically your practice questions. Practice questions, just pause the video and try to solve them. Let me just do a first question, right? We'll discuss first question. How many tissue boxes of size 10 into 8 into 9 can be adjusted inside a cupboard of size? Question was given that how many tissue boxes? Some tissue boxes was there. How many tissue boxes can be stored or adjusted in a cupboard box? Cupboard box is obviously the large one. So a size is given 36 into 40 into 100 centimeters. So just equate the volume. Just equate the volume. You were asked to find out how many tissue boxes. So the volume of these cupboard boxes, the volume of these cupboard boxes will be equal to n times of volume of your tissue boxes. Volume of your tissue boxes, right? So volume of cupboard boxes is 36 into 40 into 100. Okay, just be careful writing your units also, right? Will be equal to your n times. Suppose n number of tissue boxes will be placed inside a cupboard box. So n times of volume of your tissue box. Whatever the variation of tissue box, 10 into 8 into 9, this volume will be your n into b into x. So 10 into 8 into 9. Just try solving 9 4 the 36 4 times. Then divide 10 into your 40 will be also 4 times. Then 8 is there. Then 4 will cut 8 into 2 times. And 2 will cut 4 into 2 times. So n will be equal to 2 into 10. 2 into 100, sorry. So n will be your 200 number of tissue boxes can be adjusted inside a cupboard box, right? So guys, try just solving them whole thing. So yeah, solution also there. We have calculated one. First question: 200 boxes can be stored in your cupboard boxes, right? So guys, this is all about our session. Thank you very much.